Alright, g'day Year 10s, back with a bit of review of Year 9 work here, factorising quadratics, and a particular sort, the monic quadratics, or as you guys think of them, the easy ones, the ones where the value in front of x squared is always 1. So quadratics, remember, they're in the form ax squared plus bx plus c, where a, b and c are numbers, basically. And these are the ones where we've got a 1 in front of the x term. What we want to do to factorise means to write as things being multiplied together. Usually we end up with x plus a number multiplied by x times another number. X plus another number. Those two brackets being multiplied together, that's what we're after. Let's have a look at some examples. I'll go through a few different ways of doing these. You may have done them differently in Year 9. Eventually, with these monic ones in particular, we would expect you just to be able to write down the answer. One thing to bear in mind, there are a few little clues that we're given along the way when we're doing these. And that's to do with the signs. This sign, if it's positive, tells me the sign in each bracket, S-I-G-N, in each bracket, is the same. So either both positive or both negative. The first one, that gives me the sign of the largest factor. And that's going to be important. Just it'll help you get to your answers a little bit more quickly. Why does this have to be the same sign? Well, because how do I end up with a constant term? It's this m multiplied by n. If they're both positive, I'll end up with a positive. If they were both negative, a negative times a negative would also give me a positive. So if it's positive, the sign is going to be the same. If it's negative, you're going to have different signs. This one here, well, to end up with a positive, I have to have at least one positive product. So that makes perfect sense. Let's have a look and see how we go. Just factorising some, jogging our memory from last year. Here I need numbers that multiply to 15 and add to equal 8. Well, 3 5s are 15 and 3 plus 5 is 8. So I know that I'm going to have x plus 3, x plus 5. Fairly straightforward, that one. Here I've got another one here, x squared minus 5x plus 6. And I could do it the same way. I'm going to step you through how to do that. So the signs are going to be the same. Because this one's negative, they must both be negative. So I can even write x minus something multiplied by x minus something else. Now I just need to try the factors of 6. What are the factors of 6? 2 and 3 and 1 and 6. Well, let's try 2 and 3 first. X minus 2 times x minus 3 times... Yep, that'll give me negative 5. See how those two terms, negative 2 times x and x times negative 3, that's going to give me negative 3x. This inner product was going to give me negative 2x. That's where the negative 5x comes from. So we can always check our answers just by doing the expanding in our head. That's another good way to make sure we're on track. Alright, 2x squared minus 10x minus 28. Hey, you said we were doing monic ones. It even says it up here. But I've got a 2 in front of this one. What do you have to do always when you're factorising before anything else? Even with quadratics? That's right, check for a common factor. If I check for a common factor there, I could write this one as 2. Outside of x squared, take 5x, and 28 divided by 2 is 14. Right, two negative signs. So when I go to factorise this, I can just leave the 2 at the front here. I'm going to have x plus something and x minus something. So the factors of 14 are going to go in here. Well, let's try 1 and 14. This tells me the larger factor is going to be the negative one. So if I had plus 1 and minus 14, well, 1 minus 14, negative 13, that doesn't look like negative 5, does it? That's not going to be any good. What are other numbers that multiply to equal 14? What about 2 7s? Let's try that a go. 7's the larger one. This tells me the larger factor has to be negative, so I'm going to put a negative 7, which must mean the 2 goes there. Let's check. Am I going to end up with negative 5x? There's positive 2x. Negative 7x, that's the one we want, isn't it? Negative 5x would be the sum from those. That's good. Last one here, x squared minus 8x plus 16. Numbers that multiply to equal 16 and add to negative 8. Well, both signs are going to be the same, and they're both going to be negative. So I'm going to write x minus something else. What numbers can I try for 16? Well, 16 and 1, that's not going to give me negative 8. What about 2 and 8? Minus 2 minus 8, no, that'd be negative 10. What else makes 16? 4 and 4. X minus 4, negative 4x minus another 4x, negative 8x, we know we've got the right one. And you can see that one you could even write as x minus 4 all squared. They're fairly straightforward ones. I did promise you I was going to show you another method, so let's have a look at how we could do that x squared minus 8x plus 16 again. And I alluded to this one the day when we were doing our expanding right back last week, at the start of last week. What I'm going to do is I'm going to think about the x squared and the 16. That's where they appear. The minus 8x is going to be made up of this number that goes in there and that number that goes in there. So here I'm going to have x minus something, and this is going to be x and a minus something, and we just needed to fill in the blanks. And that's where we can trial the numbers. So if I did negative 16 and negative 1, then this would be negative 16x, negative x. Oh, negative 17x doesn't work, does it? So it's exactly the same as what I was doing. Whoa, erased slightly too much there. It's exactly the same as what I was doing in brackets, but some people will find it easier to do it in the box. Oh, I've done it again. And that's okay. If you find it easier to do it in the box, do it in the box. That's fine by me. Negative 4 and negative 4. How does that work? X times negative 4 was negative 4x. Not very good with the eraser, am I? And x times negative 4, negative 4x. You can see there, x squared minus 8x plus 16. Yep, same thing. And then my two terms in the brackets, x minus 4, x minus 4. Which, of course, is x minus 4 squared. All right, there are some for you to try. Do them now, and you'll then have a chance to check your answers. Pause the video, and then we'll come back and see if there's anything else left to do for this exercise. Good luck. All right, there you have it. You can always check your answers by expanding, but if you want to, you can just check with mine as well. 3x and 4x, 7x, and 3 4s are 12. That one worked. Signs the same, both negative. Negative 4x minus 6x, negative 10x, negative 4 by negative 6, positive 24. They're looking good, aren't they? This one here, remember C, take out that common factor first. I was left with x squared, take x, take 6. Numbers that multiply to negative 6 and add to negative 1, negative 3 and 2. And the last one, a perfect square again. It's often a clue if that number's a square number at the end. It might be a perfect square. In this case it was, so it worked out nicely. What else do we use these for? Simplifying some algebraic fractions. So remember, you can only cancel common factors. I can't go and just crazily cancel out those x's there, as some of you want to do. Not anymore, of course. You would never do that. I've just deleted everything. How did that happen? Control Z. Well, that's better. Good thing that worked. Let's see what I can do here. I can factorize, then I've got factors. Maybe then I'll be able to cancel. X squared minus x minus 6. That's one we just looked at, isn't it? X take 3, x plus 2, divided by x plus 2. Oh, there's something that will cancel nicely. And I know I'm working across the page. I don't have as much room as you'll have. Please work down the page when you're doing your working. But there we go. That can be simplified down to x take 3. This one here, let's simplify each bit. Favorite rule in maths, difference of two squares. X plus 3, x minus 3. On the bottom, signs will be the same, will be different. So x plus something and x minus something. The larger one will be negative. Numbers that multiply to 15 and add to negative 2. That'll be negative 5 plus 3. Multiplying on the other side, I need, again, a positive and a negative in each bracket. Numbers that multiply to 5 and add to negative 4. That'll be negative 5 plus 1. That'll be negative 5, and negative 5 plus 1 would be negative 4. That's looking good. Last one here, it's not a quadratic, but we can still factorize. Take out the common factor. 2 outside of x take 3. Now we are just crossing out common factors because we're allowed to factorize finally. X minus 3, x minus 3. X minus 3 divided by x minus 3 is 1, so they go to 1s. Here I've got an x plus 3 term and an x plus 3 term. They can cancel. X minus 5 multiplied by x minus 5. What's left over is not very much, but we can write it down now. So on the top, 1 times 1 times x plus 1. So that's just x plus 1. And in the denominator, 1 times 1 times 2 times 1 is just 2. So x plus 1, all divided by 2. As always, a couple for you to try, and then we'll be getting into your exercise very shortly. Good luck. Just have a go at those. Pause the video, come back and check, and then we'll see you in the next one. Cheers, guys. And there you have your answers there. Remember, factorize, get common factors, then you can cancel common factors. simplify your answers that way. So I've got x minus 4 for the first one and x plus 4 all divided by 2 for the second one. Remember to get stuck into all of your quick points exercises. That revision is going to be really important for you. Oh, I was zoomed in a long way there. Hopefully you can still all read it fine. Yep. Your basic training, you guys are doing a good job. Remember, at the end of the day, click back here, click on the form to say what you've completed and how you found everything. Keep up the great work. We'll see you in the next video. Bye, guys.